Hello, I'm James, and together with my partner Ben, we are Data Forensics, part of iSchool Capstone Group 55. I'm presenting our project, Data Forensics. And in this project, we've partnered with our sponsors, the Data Afterlives Group, which is composed of faculty and researchers from the University of Washington and the University of Texas, and their members are Amelia Acker, Megan Finn, and Sarika Sharma. Beginning with a quick overview of our research, in 2011, the NSF required applicants to submit a data management plan and agree to make publicly accessible research funded by NSF-awarded grants. The goal of this project is to search these awards to see if we can find the data associated with different NSF projects and determine how the data is stored. We sought to understand, 1, if we can find data from NSF projects, 2, how researchers store data created as a result of projects funded by the NSF, and 3, possible pathways for retrieving science data. Working from a list of NSF projects provided by our sponsors and spanning a variety of NSF research areas, we applied a systematic approach in recording our findings. We've been investigating NSF projects in multiple research areas from 2011 to 2018, and these include oceanography, secure and trustworthy computing, civil, mechanical, and manufacturing innovation, science and technology studies, and the division of biological infrastructure. Using lab notes, we collected data about the location, availability, and reuse of data from NSF-funded science. Through detailed note-taking, we developed systematic workflows for searching and identifying a variety of outputs, with a focus on locating datasets associated with NSF projects. We searched for data sourced from 88 NSF awards. This graph illustrates the accessibility of outputs we located in our search. Though datasets are the primary focus of our search, this graph accounts for all outputs located, which is mostly comprised of publications. Accessibility for this project is about whether we could find the data associated with an NSF project. Searching publications is an important step in searching for datasets, and the accessibility of these publications is an important factor in furthering the research to locate related datasets. This graph measures our success when searching for datasets. Of the 88 awards searched, we were only able to find data for 16 of the NSF awards. This graph is useful in showing how difficult locating datasets can be and how much work remains in making NSF-funded data more accessible. As you can see, we experienced greatest success in the oceanography and division of biological infrastructure research areas. In addition to the overall success of these searches, this table further breaks down the instances where datasets were located and lists the repositories used to store data found within each NSF community. As stated earlier, DBI and OCE yielded the most discoveries and exhibited a greater utilization and variety of repositories to store datasets tied to NSF-funded research. And now a discussion as to the implications of our findings. When it comes to information professionals, the timing of this research is well placed as greater attention is being put on scientific communities and the need to make the results of federally funded research accessible and open to the public. Our research fits within the greater Data Afterlives project by examining how researchers deposit and share their data. As part of the NSF grant process, researchers explain through DMPs the types of data outputs that are expected as a result of their project and explain how this data will be disseminated and stored. Our research shows how the different scientific communities follow through on these plans, and our research is instructive in shedding light on the actual practices as we attempted to locate data outputs using the NSF award search. In regards to national policy, at the beginning of this year, the Biden-Harris administration announced the Year of Open Science, an effort made by the White House office to improve research infrastructure participation and allow for greater access to the results of federally funded research. Our data forensics project illustrates the challenges of data sharing and data storage practices. In presenting this work, we are shedding light on data accessibility and how challenging finding data is and how much work remains to align the current state of scientific research with the requirements of national policy. Looking into how this research might be built upon or expanded, there are multiple avenues to pursue. One could increase the scope by adding the number of awards searched, or perhaps narrow down to focus on specific research areas. Another way is to key in on specific aspects of data preservation. and to highlight the specific repositories and their usage by NSF researchers. I'd like to conclude this presentation by thanking our sponsors and iSchool faculty.